Hi everyone, welcome back to another Pre-Calculus 12 video. Today I'm going to be moving on to 3.3, which is the division of polynomials. So we're carrying on in the polynomials chapter. And you'll notice that I have written up a little bit of a review for you. So this is content that you're familiar with. This is going way back to when you first did long division just using regular numbers. And I've only done that, I've color coordinated it so that you can be quite clear on the vocabulary. And I'm basically just using these numbers in long division so that you can be reminded of what the different terms mean. So we'll start off here with 5 in the numerator. That's called the dividend. The 2 at the bottom is the divisor, so the thing that we're dividing by. And when we take that and set it up this way, as a long division setup, you'll notice that the divisor goes on the outside, the dividend goes underneath here, and what we get as our answer is the quotient at the top. And then of course we would go in the circular motion. 2 times 2 gives us our answer here of 4. We would subtract top to bottom here, 5 minus 4, and we'd get this purple remainder at the bottom of 1. So we're done with that, and the only reason that we did that is so that we could use it to apply it to our polynomials, which is what we're working on today. So notice that I've tried to keep it consistent here. I still have my divisor on the outside, but this time it's x minus a. I have my quotient, or my answer, that would end up at the top. I'd have my dividend underneath. And then whatever I get for my remainder would be at the bottom here. So it looks similar to this thing that we had over on the left. And our statement, or how we would write our solution down here, would be p of x equals x minus a, so the divisor, times the quotient, q of x, plus whatever the remainder ended up being. And if you're ever unsure, you could always multiply this all out again, and you would get what you had for the original polynomial. Okay, so the reason that we're learning this is so that we can use this to factor and find the zeros of our polynomials. So the first thing we'll start with here is long division of our first example. So I'm going to take this and rewrite it. I have f of x equals 6x squared. This is another way we could write it. 6x cubed minus 19x squared plus 11x plus 6. And that whole thing is being divided by, well, if we're told that we have a 0 of x equals 2, then we would be dividing by x minus 2 because that must be a factor of our polynomial. So we would divide this all by x minus 2. I don't really need the brackets, but I'm going to put them there just to make this nice and clear for us. And then when we go to set this up, we would have, actually this time maybe I'll leave the brackets, but we would have x minus 2 on the outside here. We would have our 6x cubed minus 19x squared. Notice that it goes in descending order, x cubed, x squared, x, and then just the constant. If not, I would put in a 0x here as a placeholder, but since I do have a plus 11x, I can just write that. And then I can just leave things like this. And I'm going to get fancy here and move this up so that it's out of our way, and so that I can work my way through this and get our solution. So here's how we go through this. So pay attention to the process because it's not difficult, but it requires a little bit of, well, I guess there's a bit of a step-by-step system to it. So we're going to take our first term and we're going to divide these out. So I've underlined them in blue here. I would take this 6x cubed and I want to divide it by x. I would get 6x squared, and it's, okay, you don't really have to do this, but I'm going to do this to make this super clear to you. It's sort of like we have our lanes set up vertically for each of our terms. And you don't want to mix up things in your lanes because a lot of mistakes can happen that way. But when I divide this 6x cubed by x, and I get 6x squared, I put that in the x squared lane. And from there, I'm going to multiply this out by this and this, and I'm going to put my solution down here. So 6x squared times x gives me 6x cubed. I was expecting that, and if ever I don't get that, I know that I've made a mistake. And then 6x squared times minus 2 is minus 12x squared. And then top to bottom, I'm always going to be subtracting, just like when I did my long division with my numbers. So these would be gone or canceled out, and then I have minus 19x squared minus minus 12, so I'm actually adding 12. So I get minus 7x squared here. And now that I've done that, I would do the same pattern or cycle that I started with at the top with my 6x cubed. I would take this and divide it by my x here. So negative 7x squared divided by x gives me minus 7x, which goes at the top, and now I go through and I multiply this by both terms, and I write both terms at the bottom here. Sorry, I forgot to do this, but I'm also going to bring down the 11x. So when I go and multiply this, minus 7x times x gives me minus 7x squared. I was expecting that, and I know I'm going to be subtracting these. Then minus 7x times minus 2 gives me plus 14x. And then I'm just subtracting these top to bottom. So when I do that, I was expecting for these to cancel out, which they do, because this becomes a plus 7x squared, so they're total opposites. And then 11x minus 14x, I'm getting minus 3x. I'm going to bring down this plus 6, so I have plus 6 here. And now I'm on to my next step here, which is taking this minus 3x and dividing it by my x term here. Minus 3x divided by x gives me minus 3, and I go through the same process where I take the minus 3 and I multiply it there, and then I write it at the bottom, and I was expecting this. I get minus 3x, and I get plus 6. Look at that. This worked out perfectly so that I don't even have a remainder on this one. So, in order to be able to make sense of this whole thing, I'm going to carry on up here, and I'm going to rewrite it in our division statement. F of x equals 6x cubed minus 19x squared plus 11x plus 6. This is the original thing that we started off with. So to show what we've done here, or why we're even doing this, we would say that this is equal to this x minus 2 that we were already told is a factor, and then the other part that we just got as our answer up here. So times 6x squared minus 7x minus 3, and then x minus 2. And I want to take a look at this, and well, I noticed that it's a trinomial, an AC trinomial. So I don't know if you remember this from way back, but we learned how to do factoring trinomials. And so when I factor that out, I actually get 2x minus 3 and 3x plus 1. And so therefore, I'd set them equal to 0, so I'd have x minus 2, 2x minus 3, and 3x plus 1. And so I know that my roots, or my solutions, or my x-intercepts, or my zeros, because they all mean the same thing, would be 2, and from here it would be negative 3 over 2, and from here it would be negative 1 over 3, and that's what I would get for my answers. So basically, to put this all together, or to go back to this, what this allows us to do is to take polynomials that aren't able to just be factored the way that we've learned, all the methods of factoring we've learned over the years. We can't use those to break something like this down. We can use our long division method in order to be able to divide this and break it down, and then break it down into factors, and to be able to come up with the roots or the zeros. So you'll see this is a step along the way that's leading us to the point where we can use this to graph things out and to figure out what's happening. Okay, moving on. Let's try another one. Again, as you're doing this in your videos, what I would like is for you to hit pause right now and try this one on your own. But before you do that, you haven't seen something like this. I mentioned it in the last one, but you must use a zero coefficient to replace missing terms. So maybe just before you hit pause, we could go over that. 3x cubed minus 2x squared, and notice that it just jumps to 1. So I'd put a plus 0x plus 1. So this is basically like, that's nothing, but you would have it there as a placeholder, because in your solution, in your quotient, you will likely have an x term. So this will allow you to keep track of things. So we set it up the same way. X minus 2. In here, I'd have the placeholder and all that stuff that I had actually. Isn't this wonderful? Let's take this. This is laziness at its best. And let's write it down there. Okay, so we'll go through things the same way. 3x cubed divided by x would give us 3x squared. I then multiply it out by this and this. So I get 3x cubed minus 6x squared. And I know that when I go from top to bottom, I subtract. When I do that, I get 4x squared because I'm doing minus 6x squared here, so that makes sense. And I don't really need this, but I'm going to put it there just so we can keep track of things. And from this point, I am going to divide out 4x squared by x, and I would get plus 4x. This is making you realize why we had this 0x placeholder. And now we're going to go through this in the same manner. 4x squared, when I multiply that out, and then 4x times minus 2 gives me minus 8x. And I know that I'm subtracting them top to bottom, so the 4x's are gone. But this becomes a plus 8x at the bottom here. And then I would bring down this plus 1. And my last step, I would do 8x divided by that, so I'd get plus 8. And then I would go through the same process. 8 times x gives me 8x. 8 times minus 2 gives me minus 16. And when I go through and subtract these, I actually get 1 plus 16. So 17 is my remainder. Okay, so you see what that little phrase means. That was the 0x placeholder that we've put there. And so now we can take what we've done and we can put it together to come up with our solution. So therefore, I can say that my original, which is under this little thing here, 3x cubed minus 2x squared plus 0x plus 1 equals all the stuff that we factored it out to. So this x minus 2 that we were told about times what we found as the quotient at the top here. Oops, it's not, there we go. Times 3x squared plus 4x plus 8. And we're not quite done because we would want to factor this out if we can. And we're not able to. We can just leave it as is. So from this, sorry, I forgot something very important here, and I'm going to even color code it. I didn't put the plus 17, and that has to be there. We have to have the plus 17. So again, if you are unsure, this is how you can always check. This left side should always equal what we have on the right side. So if you were to multiply all of this out and add the 17 at the end, you should get the same thing as what you have on the left side. You can try it out if you like to double check. And the only other thing that I'm going to show you is that this is exactly the same thing as writing 3x cubed minus 2x squared. We don't really need to put the 0x, so let's forget about it. Plus 1 over this x minus 2, so we can move the factor to the left side and leave it with just the quotient. So this 3x squared plus 4x plus 8 and then plus 17 over x minus 2. And the reason for that is if we want to divide out this x minus 2, we would have to divide it by everything on the left and everything on the right in order to get rid of it. So that's how we ended up with it down here and over here. Both of them are exactly the same thing. I've just shown you this and this in case you're working your way through a solution and you don't see this as one of the listed answers. It's important to know that they mean the same thing. Okay, moving on. Here's the general, basically this is just a recap or a summary of what we just went through. The division algorithm. So you have your dividend equals the divisor times the quotient plus the remainder. So this is what I just showed you using examples. And here are some steps to summarize what it is that we went through. And moving on then to synthetic division, which is basically a shortcut to long division. You will be asked to solve things using either of the methods. So yes, you do need to know how to do long division, but if it doesn't specify in the question, it's entirely up to you. You get to choose or decide which one you prefer to use. What I have found from experience is that most people choose to use synthetic because you're about to see that it's a lot quicker to go through. Okay, so here is the first thing that we would do. We would take this and rewrite, and we're going to look at all the coefficients. So there's a 2, there's a minus 5, actually, why don't I put it in front of here, because that's not the coefficient, that's the variable. There's nothing there, it's a 1, and then a minus 4. Again, just like in the last example, if it's missing a term, which it is here, there's no x squared, we want to rewrite this. So we want to make this, let's make this a bit thicker. We want to make this 2x to the 4 minus 5x cubed plus 0x squared plus x minus 4. So now I have a 2, a minus 5, a 0, a 1, and a minus 4. And then I go ahead and I just take those coefficients, so 2, minus 5, 0, 1, and minus 4, and I write them out. And in the corner here, if I'm dividing by x minus 2, I take the opposite of that. So I take the root and I write it in a tiny little square in the corner here. And then I go and set this up kind of similar to what we were working with. The difference this time is we're not going to subtract top to bottom, we are actually going to add. So our first step in going through this, I'm going to start in blue, is to bring down our first term here. We're going to bring down the 2, and we are going to multiply this out by the number that's up there, and we're going to write it down here. So 2 times 2 gives us 4, and then I add them top to bottom. So I do negative 5 plus 4, so I get negative 1 down here. And now I go through exactly the same process again. I do negative 1 times 2, and I get my answer of negative 2, and I put it here. Negative 2, and then I add them top to bottom, so I get negative 2 as my answer down here. I go through the same process again. So do you see we're going in a cyclical pattern, but it's in the opposite direction to what we did with long division. So I'm going to do negative 2 times 2. I get my answer of negative 4. I add them top to bottom, so 1 minus 4 gives me negative 3. And now I go through and do the same thing again. Negative 3 times 2, and I get negative 6. I add them top to bottom, and I get negative 10. So, in order to make this crystal clear to you, 2x to the 4 minus 5x cubed plus x, I'm just going to leave the 0x out of it because we just did that for our purposes as a placeholder, so we don't need it anymore, would be x minus 2 times, so now when I look at my solution that I have at the bottom here, maybe I'll circle the whole thing, that's giving me the coefficients for my quotient, but I know that I have to reduce it down 1 from what I started with here. So if I started with 2x to the 4, I know this must mean that I have 2x cubed minus x squared, so the 2x cubed from there, x minus x squared from there, minus 2x from there, minus 3 from there, and then I must have a remainder of minus 10, which I'm going to write right here. That must be my remainder, which is what ends up over here. I'm going to put this in a box to show you that this is our final solution, and maybe I'm going to get rid of that to make it super clear. But basically, you get a sense for how much quicker or easier it is to work with synthetic division, but it's entirely up to you which one you want to use. Okay, again, good time to pause and try this next one on your own. And when you are finished, you can unpause it again or play the video to have a look at what the solution is going to be. So we're going to set this up the same way. We take this and put the 2 in the corner, and we're going to take this and have it set up over here. So we have 3x cubed minus 2x squared. Notice how there's no x, so I'm going to put a 0 there. I don't have to actually rewrite it. I think you clearly get by now what's going on here. So let's go through our process. Bring down our 3. We go 3 times 2, and we get over here 6. I add them, negative 2 plus 6, so I get 4. And then I multiply it, 4 times 2. I get my answer over here, and that's going to be 8. And then I add them top to bottom, so I get 8. And then I multiply that, 8 times 2, and I get 16. And I add them top to bottom, and I get 17. And I don't know if you noticed, but this actually is the same question that we started off with, but it's nice to see a different form of that solution. So this 3x cubed minus 2x squared plus 1 ends up giving us the thing we were dividing by, so x minus 2, times what we just found. If I started with a 3x cubed here, this must mean a 3x squared plus 4x plus 8, and the whole thing is plus 17 at the end because that's my remainder. And then there is my overall answer. Okay, one last example to show you an application of what this might look like. But again, what I would like is for you to try this on your own. So hit pause, try this question on your own, and then when you are ready, play the video again to have a look at the solution. It says use synthetic division to find k, and notice that this is looking a lot like the other questions, except there's a plus k at the end. So we don't know what the constant is. We need to figure that out. But this time we are still given what we're dividing by, and we're also told the remainder. So we're sort of working backwards to find the same information. Don't let things like this throw you off. Use the same step-by-step method. So you want to take this minus 1 and set it up over here in the corner. See, in this question it does tell us to use synthetic division, so you do have to use it instead of long division, which you'll probably want to do anyways. And then let's take this. We have a 2. We have an x squared next, so I can put a 1 there. We have a minus 5x, so we don't need a placeholder. And then at the end we have a k. So I'm just going to pretend that the k is no big deal for now. And then when I look at this, it also tells me it has a remainder of negative 3. Well, we know that the remainder must end up at the end. So always a good idea to sift through the information and find or fill in any information that's given to you, and then start to put the pieces of the puzzle together to find what you're missing or what you're looking for. So I'm still going to just carry on pretending that this is a normal question until I hit the point where I can't go on anymore. So bring the 2 down, multiply that out. 2 times negative 1 gives me negative 2. I add those, I get negative 1. I do negative 1 times negative 1, I get positive 1. I do negative 5 plus 1, and I get minus 4. And when I do minus 4 times minus 1, I get positive 4. So this actually isn't too bad. So you see what I mean by don't let this stuff throw you off. we know that when I look at this last little column here, I'm going to move this off to the side. I know that the top number plus the bottom number should equal my answer. So I'm basically just dealing with a basic algebra question. I want k by itself, so I want to move this over. How I move that over is subtracting 4 on both sides. So k is equal, well, that would be gone, so we get minus 7. And of course, you could plug it back into here to double check that it does in fact make sense. And it does, it works, so we know that it's good to go. Okay, so there's your suggested work for the day. And again, just a reminder, OL means odd letters. And this is the suggested work. Of course, you are welcome to do more if you feel you need extra practice. And similarly, if you go through and find it repetitive and hit a point where you feel like you know the stuff, you are welcome to do less. So you figure out, know yourself and figure out how much you need.